Welcome back, guys. In this video we're going to look at graphs of motion, and I had told you that you have displacement time graphs. That is a graph where you plot displacement against time. Now in this video we are going to look at the velocity time graphs. When we say velocity time graph, it is a plot of velocity on the y-axis against time on the horizontal axis. Now, under this case, we are going to look at the different scenarios of velocity time graphs. Now, let's begin with the body moving with constant velocity. When a body is moving with a constant velocity, and we happen to plot a graph of velocity against time. And please take note, when you're plotting your graphs, you should make sure these graphs are labeled. They should be having the quantities on both the y and the x axis. Now, if a body is moving with constant velocity, it means that its velocity is not changing, and therefore that graph is a straight line, just like that, to show that as time is increasing, this velocity of this body doesn't change. Now let's look at category number 2. We are looking at a body moving with constant acceleration. Body moving with constant acceleration when the initial velocity u is not equal to 0. If we have our body that moves with the constant velocity, when we say u is not equal to 0, it means this body was initially moving with a certain speed which is not 0, and this is how our this is how our graph would look like. Now let's look at scenario C, where we have the body moving with uniform acceleration. Now, if a body is moving with a uniform acceleration and is a plot of velocity against time, then our graph is like that. And if we happen to get a tangent, let me use red. If we happen to draw a tangent to this curve, the tangent, more clearly, this is not bringing it out right. If this is our graph and it is a curve, and you happen to draw a tangent at one point, where you draw the tangent, at that point you get what we shall call instantaneous acceleration. You'll get instantaneous acceleration, and this shows us that this body is moving with a uniform acceleration. Now let's look at another graph when a body is moving with when a body is decelerating uniformly. when a body is decelerating uniformly. Now we know that deceleration is the same as a decrease in speed. Now if we had a plot of speed against time and you're decelerating, this means that as time is moving on, your velocity also continues reducing until you stop. When this line goes and reaches this zero axis of velocity, that would mean that you have that would mean that you have stopped, since your velocity has become zero. Now let's look at another one. Let's look at another scenario where a body, this is when a body is thrown vertically upwards. When a body is thrown vertically upwards. Now, when a body is thrown vertically upwards, this is if we are plotting velocity against time. When you throw a body vertically upwards, it moves with a decreasing speed until it reaches maximum height. And when it reaches maximum height, we say that the speed at that point is momentarily zero. And after reaching maximum height, the velocity of this body again increases, but that velocity becomes negative, and that is in line with the sign conversion that we shall see ahead in motion and gravity. So therefore, guys, make sure you take note of these graphs of ours. Take note of these graphs because they are also among the set questions. So to be on the safe side, make sure you understand them and you know how to draw each of them, because they will be required in an exam at one point.